Next thing we have to cover is how to know if a function is increasing or decreasing on an interval. So if a function is increasing, that means the slope is positive, right? The line is going up. Anytime your line is going up in any type of way, it's increasing. Anytime it's going down in any type of way, it's decreasing, right? How can you find this with math, with calculus, instead of just looking at a graph? Anytime f prime of x is a positive number, anytime it's greater than 0, it's going to be increasing, right? Because it has a positive slope. And anytime your f prime of x, your derivative function, is less than 0, it's a negative slope, it's going to be decreasing. How can we use this in functions? So let's say we have this function right here, f of x equals 3x squared plus 6x minus 18. And we have to find when it is increasing and when it is decreasing. So the first thing we have to do is we have to find our critical points, because anytime you have a function and it changes, the slope changes, like here it's positive, here it's negative, or here it's negative and here it's positive, right? Anytime the slope changes, it passes over a critical point where the slope is 0 in order to change. So the first thing we do is find the critical points. So to do that, we derive the function f prime of x equals 6x plus 6, right? And we set this derivative function equal to 0. So we get 6x plus 6 equals 0, 6x equals negative 6, x equals negative 1. So our only critical point here, since it's not on an interval, is negative 1. So we have our critical point of x equals negative 1. We know that at negative 1, the slope is 0. So we have to find out what's going on right before that, what the slope was, and right after that, what the slope was, because negative 1 is the only time where the slope is going to change, right? So we'll put negative 1 on a number line, and we'll say left of it what's happening and right of it what's happening. So to find that out, we have to pick a number smaller than negative 1 and plug it into our derivative function to see what was going on with the slope. So let's pick negative 2, right? If we plug negative 2 into this, we'll get negative 12 plus 6. This is negative 6. It's a negative number. That's all you have to know is a negative number. So before negative 1, the slope is negative. If you pick any number less than negative 1 and you plug it into this, you're going to get a negative number. The slope of the function before negative 1 was negative. And let's plug in a number bigger than negative 1, right? Let's plug in 0. If you plug 0 in, we get 0 plus 6. It's going to be a positive number. So on the right of it is positive. So our function is going to be decreasing until negative 1, and then it's going to start increasing afterwards, right? Because negative 1, the slope is 0, and before that it's negative, afterwards it's positive. So in math terms, f of x is decreasing on the interval negative infinity to negative 1, and increasing on the interval negative 1 to infinity. So this is the notation for it. You see anything less than negative 1, right? From negative 1 to infinity, the slope is negative, and from negative 1 to the infinity on the right, it's positive because it's a parabola. It looks like this. So let's try to do the same thing with this function right here. Y'all go ahead, pause it, try to find when it's increasing, when it's decreasing. Do it right now. All right, cool. So first thing we have to do is find the critical points. To do that, we derive the function. We'll get f prime of x equals x squared plus 2x minus 35. And then we have to set this equal to 0. And this is low-key, like, hard. So we got to factor. We'll get x plus 7 and x minus 5. So our critical points here are going to be x equals negative 7 and x equals 5. Just like before, let's draw our number line. We'll put a point at negative 7 and we'll put a point at 5. So we have to see first what's going on when x is less than negative 7. So if we have our equation x plus 7 and x minus 5, if we plug in a number less than negative 7, x plus 7, this first part here is going to be negative. And if we plug in a number less than negative 7 on this right one, is also going to be negative. So we're going to get a negative times a negative. So this is going to end up being positive. If we pick a number in between negative 7 and 5, let's pick 0 because it's easy. We'll get a positive number for our first part. And our second one, x minus 5, this is going to be negative. So we're going to get a positive times a negative. So this is going to be negative down here. And if we pick a number bigger than 5, we're going to get a positive number times another positive number. So this is going to be positive here as well. So if we write this out, f of x is increasing on the interval negative infinity to negative 7 and 5 to infinity, and it is decreasing from negative 7 to 5. So again, all we did, find the critical points, put it on a number line, and see whether the derivative function is positive or negative. The last part of this section is that if we have a function here, and this is the graph of f prime of x, this is the graph of the derivative of a function, right? And we have to find when is f of x, not f prime of x, when is f of x increasing or decreasing. All we have to know that all this here means that it's increasing. All this here is that it's decreasing. All this here is that it's increasing. Why? Here, the f prime function is greater than 0. The f prime function of this whole part is positive. So f of x is increasing on the interval -3 to -1. And from 1 to 4, right? Because the f prime function is positive this whole time. It's greater than 0. This is just showing it with a graph instead of a table. We can also see that it's decreasing from -1 to 1 because f prime of x is less than 0 the whole time. So if it's already your derivative function, it's kind of easier because you just have to look at when it's positive and when it's negative. And that'll tell you about the original position function. That's it for this though, so we move